So I start with a kind of a landscape describing the different organizations who have interests on space weather. You can see it's a rather busy picture. You see in the top row, you see these big players, so United Nations and space agencies and EU funding programs, and then the International Science Council. And under them, there are some smaller kind of a sub-organizations. So like the ICAO, which has recently, or let's say not so recently, but anyway, got interest on space weather and space weather services for aviation, for example. Then there is a World Meteorological Organization, and there is an expert team on space weather, and I'm serving as one chair of this expert team. And then there is space agencies which are collaborating with WMO in the coordination group of meteorological satellites, and the SWESNet network, which Jussi just presented. It's under the space agency ESA, like you know. And then you have FORS, which got funding from the EU. I guess it was under this cluster for digital industry and space. And then there are other active partners under the ICS, regional warning centers, and the ISWATs, which are doing also much research on space weather. Okay, let's go forward. Okay, so I made a kind of tentative picture how T-FORS could be integrated to the WMO activities. So I'm not saying that this should be done. I just give an idea or vision how it could be done. And currently, so WMO is moving from kind of a meteorological, or has moved from the meteorological viewpoint to cover the whole Earth system. So space weather is for sure part of this Earth system, and this expert team is now trying to put in all these space weather aspects to all these massive documentations and all kind of elements which WMO has. And concerning kind of data and information change and modeling and so on, the three main elements are this WMO integrated observing system. So that's about the sensor network. Then they have this W information system. It's a solution for information exchange, so data exchange or model result exchange and so on. And then there is this integrated processing and prediction system, SWIPS, which is then platform for products. And in this schematic picture, what I have kind of sketched here, indeed, there would be kind of T-FORS would be kind of providing and extracting data using this WIS2 kind of data exchange system, and using this to get information from this WIGOS system, so observing system of space weather, and of course also other space weather data providers will be contributing to that system. And then your nice products, which we have been seeing here all the time, they would be available in this WIPS system. Okay, I go forward. So why this is a tempting idea? At least I find it as a tempting idea because in this project which you have had, you have done very much kind of already work towards the standards. And WMO, like you know, they love standards. They want to put standards everywhere to kind of enhance interoperability and those things. So when I was studying your documents, also I saw there like kind of a guidance for data policies. FAIR was mentioned, metadata models, space was mentioned there, and you are also have been discussing very much about the standards for observations quality. And then besides space weather, at least your mesoscale TIDs, it has a clear linkage also to the other parts of WMO interests. So atmospheric gravity waves coupled mesoscale TIDs to lower atmospheric phenomena. So this is kind of this forum which WMO would offer you I guess it would be relevant also for you, similarly as Vesnet is relevant for you. And you mentioned also in your documentation these kind of tsunamis and tropical cyclones and civil aviation as kind of a potential beneficiaries from your products, and these topics are very relevant for WMO. And what even more is that you have kind of covered in your project the whole chain. So you are interested about some very important data sets which would be nice to get inside to the WIGOS system. So solar wind data, solar surface images, F10.7, ionosondes and magnetometers. So all these things make, in my opinion, this your project quite interesting from the viewpoint of WMO. But there are also the other side of coin. So there are some challenges. Perhaps the most important challenge is that the WMO side, from the perspective of space weather, is not yet very mature to take you on board, if I say it very blunt way. So with the WIS2 kind of information exchange system, we have done some tests. But for example, this WIGOS system, which would be the setup of the instruments, that's still kind of it is mentioned in the WMO documentation, but the details are still very much kind of missing. About the data policy issues, perhaps that's not so big problem, but anyway. So the FAIR principles, which you are mentioning in your documentation, that's of course the best way to go forward. WMO has a data policy which is kind of dividing using two categories. Core data, it's open for everybody, also for commercial activities, and recommended data is then data which you can restrict, so you can give some licenses and restricted permission for their usage. So both of these are available and can be used, but this information dissemination system, WIS, is supporting more optimally core data particularly. And then the big question is that there is already quite many nice platforms for sharing your products and putting up your services. So why to go for WMO? Because there is quite much kind of work to do before get into the business, and of course no one can do this without additional resources. This is just a slide describing briefly the WIS2 system. So this is the kind of much information taken from the WMO side. So you have you as a data provider, you can establish this WIS2 node, and then the users they can kind of get information on your data through this global broker. So you, in order to get full advantage of the system, you need to be very careful in describing your metadata and licenses and all that stuff, so that users who are doing search for under several topics with their computer kind of approaches, they can easily find your data and they can see whether it is open data or closed data and what other properties it has. But once you have this system working, it will be, particularly from the user's viewpoint, very nice if they want to compare, for example, your TID products with tropical cyclone data or something like that, just to give a theoretical example. And if you want to start playing with this system, there is already kind of a testing environment where you can get familiar with this system. Okay, let's go forward. Currently, we are in WMO kind of talking about the user requirements because they are basis for all the activities. So finally the platform for showing your products, those products which are visible there, they should have a link to the user requirements. So I studied your documentation also about the user requirements, and I found quite interesting. So information about the characteristics of the TIDs. So they should be kind of nowcasted with time resolution of 5 minutes and space resolution. I think this is something for mesoscales relevant, and intensity characterization with 4 levels, and also latencies were mentioned and so on. But in the OSCAR space or requirements, we need to put also characterization for the input variables. So we are talking about the requirements for ionosons, for example, and so on. So I know that you have the knowledge, but I didn't find it from the documentation with my brief look. So your input in that topic would be very welcome. So how dense ionoson networks you would need to detect, and what would be enough, what would be the goal, and what would be a kind of intermediate between those two kind of borders. And yeah, so yes, we are talking about the ionoson parameters, for example, and then there is this collaboration with a coordination group with meteorological satellites. So the space-based part, so space-based observations, they are progressing quite well in the WMO framework, but with these surface-based observations, we have still some problems. And here I just give you a kind of example about the form which we need to fill up when we put in the requirements. And as the FOF2 is one, perhaps a good, interesting parameter, I took this example. So you can see these are fixed how we need to put up in these different attributes for this variable. So there is some kind of a high horizontal resolution goal, breakthrough, and threshold. And then there is also something to say about the stability and about this is observation cycle, what is mentioned here. So what is the time resolution of data? We have currently now 5 minutes. 15 minutes would be already a good. And if it is less than 60 minutes, then it's not so useful. And this is the latency. So you can see that this form may not be exactly optimal for feeding in information about FOF2, but this is anyway what we need to use. So if you have any opinions on these kind of parameters, I would be more than happy to hear about them. Okay, I go forward. This is now the from WIGOS. So WMO has very extensive manuals. Perhaps you have been studying them quite much or not. Anyways, so they have quite much kind of detailed information about their requirements. And this is a metadata standard, what I found from the manual, WIGOS manual, but I have also put here, I studied a bit about the space data model, and you know this better than I do, that they have in space, you have these 3 main categories, one characterizing data, one characterizing its origination, and one about the infrastructure resources. And I kind of roughly see that there is some resemblance with this WIGOS metadata standard, and I kind of think that I can kind of recognize some connections there, but it's still, there is, I believe, quite much work to do to get to make the match between space format and this what WMO currently have. Most likely we can modify this later on, but currently we have this template. Okay, let's go forward. Then about this processing and prediction facility, so WIPS platform. Here I just have kind of listed the main features or elements what the WIPs currently have. So it has a web portal which is giving a summary of the networks or and centers who are providing the products, and then there are links to the products. So, for example, FORS could be one of these data or service providers, and then this would be a link to your FORS pages, perhaps, which NOAA is planning to maintain, and they are maintained as a federated services in the same way as with SWESNETs. And then there is a dashboard which from where you can follow how much your products are used. So that's also quite interesting information. And then there is this newsletter functionality where you would have an opportunity to kind of disseminate about your upgradings to a larger reader community. Then there are two other elements which I think there are still much work to do, because for those we will need to find lead centers which understand the challenges of space weather and can therefore conduct these kind of verification and quality monitoring tasks. But I have mentioned here, for example, for magnetometer data, that the intermagnet or supermag communities could serve as a pilot to lead, for example, the quality monitor of magnetometer data provided to the system. And then this is my last slide. So as a conclusion, I say that indeed I see in FORS quite many features which would be, for which reason I think that the activity, your project would be a good pilot for WMO collaboration. Like I said, so you have been working very much with the standards and you have very relevant products. But indeed, it is not an easy task. So it's a bit like a jump into cold water. Some people enjoy it, and it's much more fun if there is a larger group jumping in. So I kind of hope that if we get the kind of the wheels turning more and more, kind of a space where the data providers would consider also this WMO framework as a framework for them to disseminate their products and capabilities.